Welcome, viewers, to another episode of the It Depends podcast. In the month of June 2026, I attended two bellwether events. One was Snowflake Summit 2026, and then followed by Databricks Data and AI Summit. So what I've done is I'm recording two podcasts back to back. The first one talks about key highlights and announcements from Snowflake Summit, and then the second one that will follow will do the same for Databricks. So with that, let's get started. I have a lot of content to share. Before I go there, I want to bring to your attention that I have a book coming out next month or mid-August from Wiley called Designing the AI-Driven Data Foundations. So with that plug, I will move on to the agenda. So let's look at what transpired at Snowflake Summit 2026. Last year, I had done my blog on the same event and I'd written 16,000 people attended. This year, we had over 20,000 people. So the event grew quite significantly in 2026 over the last 1 year. What you'll see in this blog, in this podcast, is a content from a blog which I posted on my Medium site. So I've taken the content from my blog and I've put it into an agenda for today. Snowflake's revenue also grew quite healthy. It's up 33% year over year. Q1 revenue was 1.39 billion. The fiscal year 2026 revenue is 4.68 billion. The other interesting thing is I was going back to my last year's blog, which happens to be a sort of a time capsule. And in that, I'd written that Snowflake had crossed 5,000 customers. They were at 5,200. This year, 13,900, out of which 13,600 are using their AI capabilities. So it's a very impressive number. It's almost all their customers are now using the AI capabilities. So what are those AI capabilities and what goes underneath that? This is a picture from a Medium blog. I tweaked it a little bit to tell the story. So if you attended the event, then you would know that a lot of time was spent talking about CoCo and cowork. CoCo and cowork are right here in my diagram, but I'm going to start here and then make my way through till we come to the end. So, to be honest, I think Snowflake may have over-indexed a bit on CoCo and cowork, but that's probably because this is a moment of AI. So everybody's focused on AI right now. But the real magic is happening in the layers underneath that feed into AI. In fact, AI is not a standalone thing. AI is everywhere. In every layer that we talk about today, you will see that there is some use of AI to help us humans do our tasks better, or even more, let agents do tasks on our behalf. So with that, I'm going to start with the data platform. So what is a data platform that we are talking about? So in this deck, what I did was, in order to appreciate what is new, I decided to go back into the history and then tell the story moving forward. When Snowflake started, the way it launched its separation of compute and store was what we now call Gen 1. So in Gen 1, as all of you who use Snowflake know extremely well, you go and provision a compute cluster, which is called virtual warehouse, and you pick a size, small, large, extra large, 2x, 3x, and so on. So you have to predetermine the size of the compute cluster. Not very cloud-like, to be very honest. It's cloud is supposed to be based on consumption, but you are forced to choose a size upfront. So that still remains, by the way, has not changed, but there is now something called Gen 2. So in this chart, you see at the bottom are instances where the end user has full control. Above is more of an automated. These are general purpose on this side, and these are specialized use cases. So if we look at where I, as an end user, has full control, but it is for general use case, now Snowflake by default, when you create request for compute cluster, it is Gen 2. What is Gen 2? Gen 2 has a lot of optimizations in how the queries are executed, how the resources are consumed. It also uses much faster chips. For example, just in the days before Snowflake Summit, Snowflake signed a $6 billion deal to use AWS's brand new Graviton-based chips, so instance types that use Gravitron. Gravitron, by the way, is the ARMS-based CPU processor. It's not the NVIDIA GPU based instances. So what happens with Gen 2 is that the unit price goes up for the cluster, but because of the enhancements that have gone into it, it finishes your tasks much faster. So when I talk to end users, I find out that the overall TCO of Gen 2 is much lower than that of Gen 1. And anecdotally, I also found out approximately 50% of Snowflake customers have now migrated to Gen 2. And like I said, Gen 2 is now by default. If you want Gen 1, you have to then specifically ask for it. Otherwise, for all new tasks, by default, you get Gen 2. Gen 2, you still have to pick the t-shirt size. So last year, Snowflake announced Adaptive. This is where it finally takes you into more serverless autoscale, where you don't specify the size of your cluster and you let Snowflake pick it for you. This is interesting because the way this takes place is that Snowflake keeps a number of compute resources in a warm pool, and then when you request a new instance, it then immediately gives you the CPUs from this warm pool. So the latency to get the cluster is low, and you don't have to ask for the size. It'll auto scale as your needs grow, and you pay accordingly. Now, if we go to the left-hand side, also using the full control option, these are specialized interactive clusters are backed by something called interactive tables. These clusters are meant for if you are building a web application and you need very low latency, high throughput kind of access, then you get an interactive compute cluster. If you are doing a lot of your development, you're doing machine learning use cases, you need a ton of memory for the kind of work you're doing, then you can request a Snowpark optimized instance, and it runs on top of what's called Snowpark Container Service. So these are Docker containers managed by Kubernetes, and you can request your instance to be of the type Snowpark. Something new that was announced this year was this concept of Optima. Optima is an overall philosophy under which Adaptive falls, and it is basically optimizations that are built into the platform. And as you can see, Snowflake says Optima makes it impossible to run inefficiently. In fact, this is something very interesting because Snowflake does not announce new optimizations constantly, although behind the scenes they are regularly improving the way queries are executed. The resource consumption goes down. So this is sort of built into their philosophy. So with that, let's move to some other things about data platform that are very interesting before we move to other topics. So the first thing that I want to talk about is this whole concept of migrating data from whatever data source it may be. It may be an IBM mainframe, it could be even SAP HANA. There were plenty of end user client sessions where they talked about how they migrated. The utility is called Snowconvert. It's not a new utility, but Snowconvert AI is. So what was announced was this using AI, and in fact, we talked about CoCo earlier. Again, CoCo comes in this picture. It basically is not just doing data migration, it's also migrating your code into DBT projects. It is validating the migration. So AI is basically doing a lot of identification of any drift between source and target, and then helping with the time it takes to migrate from source to target. Once you have migrated, then Snowconvert AI can repoint your applications. Let's say your Power BI pointed to an older system, it can then automatically point to the new Snowflake instance, and just move on without any hesitation. So now in the data platform, I want to talk about operational databases. I have two slides on this. And it's interesting because this entire deck is stacked heavily on the analytics and AI use cases, except for these two slides that talk about operational data. So there are two options here, Unistore and Snowflake Postgres. Let's talk about Unistore. Unistore was the first foray Snowflake did. I think it was two summits ago, if I'm not mistaken. First time they went into the space of storing transactional data in a row store. They call it hybrid tables because behind the scenes, asynchronously, this raw data is converted into normal Snowflake columnar data warehouse kind of storage. The raw store is built on an open source database called Foundation DB. Foundation DB is actually owned by Apple. They bought it, but then they open sourced it. Foundation DB is a long tradition at Snowflake. A lot of stuff inside Snowflake is built on Foundation DB, such as how the catalog stores its data, and the policies. All that happens in Foundation DB. It's not exposed to the end user. I'm just sharing something that happens behind the scenes, and Snowflake has been quite open talking about it. Now, the second thing you see here is what was new in 2026: 8 times higher point operations, 10x faster, 10x cheaper batch loads. The reason I introduce these are the internal benchmarks against how Unistore was previously is because last year we didn't hear too much about Unistore. So there was this impression that maybe Snowflake is no longer interested in Unistore because they bought Postgres. So they now have a well-known operational database. But that's not the case. They actually do have Unistore saw a lot of new enhancements this year, as you can see on this slide. But it still begs a point that most of the world uses Postgres database. Postgres is one of the most popular, Postgres and MySQL in the open source space. And then, of course, there are the long traditional proprietary ones like Oracle, AWS Aurora, and a whole slew of them. But in the open source, Postgres seems to have won the battle. So if you have a Postgres application, then you can't really use hybrid tables. So last year, Snowflake went and bought a company called Crunchy Data, and with that, they got a pure Postgres. When I say pure, what I mean is it is not a fork. It is the actual Postgres. As soon as a new version comes out, every year there's a new version, then crunchy data, now called Snowflake Postgres, is on the latest version. Being open source, there is a lot of contributions back to the community. So, a couple of things that Crunchy team, now part of Snowflake, has done is this concept of data mirroring. What it does is it mirrors data from Postgres to Snowflake. So, mirroring is like a symbolic link, and it's like external view. So you are now in Snowflake, and you don't have to go to Postgres, but you can see Postgres data locally in Snowflake. This is already available. Very soon they'll do reverse, where Snowflake data is going to be mirrored into Postgres. So the idea is that if you're a Postgres developer and you have all your operational data, but you want to join it with you want to aggregate based on historical data in Snowflake, you can soon mirror it from Snowflake to Postgres and then see both your transactional and your analytical data in the same window, and you can join it. So that is data mirroring. The second thing they created is something called PG Lake. PG Lake, think of it as ETL or change data capture. What it is doing is it is taking data, that changed data from Postgres write ahead log, and it is moving it to Iceberg format that Snowflake can then read. We'll talk more about Iceberg. We have many slides on that. And it's bidirectional, which means you can also go in the other way. You can take Snowflake's change data and ETL it or PG Lake it to Postgres. So what it uses behind the scenes is DuckDB. There's another PG Ducks DB server that is also part of this package. Again, open source. The latency between Postgres and Iceberg is about 30 seconds. Today, if you want to do this chain data capture, then you need some sort of a connector like Debezium, which is on top of Kafka. You don't have to do that anymore. It is out of the box through PG Lake. So that's the extent we're going to go and talk about operational data. Now we get back into our regular analytical space. So in the analytical space, what happens is data engineers, so that's the first section we will look at. So I've divided this into a couple of slides here. A data engineer's job consists of ingestion and transformation, amongst many other things, but these are the two big ones we will talk about today. How do I ingest data from my system of record, my operational data stores, like support center data, CRM, teller, retail, and then how do I move it into my analytical store? So that ingestion happens in a number of different ways. The first one is the data engineer can use copy into command. This is file based, it's batch, it's manual. So obviously error prone. So Snowpipe was introduced many years ago. Snowpipe said it's still file based, but we will automate it, and we will sort of check for changes. As soon as a new file arrives, we will automatically move. So Snowpipe, but still file based. So Snowpipe streaming was introduced, which is at row level, and that was how Snowflake decided that as soon as new data is generated, instead of landing it onto your S3 bucket as a file and then reading it, we will just read it directly row by row into Snowflake. In fact, we can even look at the schema of the Kafka topic, and we can even create a table based on the schema, and that was supposed to be quite a huge enhancement. Then last year, Snowflake bought a company. It's called DataVolo, and DataVolo was a company that was created by this person who created Apache NiFi while he was in U.S. government on the defense side, and using this protocol. You are able to ingest data. You have a bunch of connectors from the source system and write it into Snowflake. So a number of new enhancements came out this year. Up till last year, as soon as data changed, you were to pull that data. Now you can set up push mechanism. So new data comes in, it gets pushed into Snowflake. When GA on Google Cloud, since it came out of defense sector, so security is really important. So having a lot of customers of Snowflake, they want to use these ingestion products, but they don't want to go over public internet. So this ability to have a private network proxy keeps the data safe inside like a private VPC, and that was something new. Snowflake also went into an agreement with Oracle to change data from Oracle. Every time data changes in Oracle, it's written into redo logs. There are APIs on top of redo logs. I remember from my time at Oracle a long time ago, there used to be an API called Log Miner, which was not very good. Oracle then introduced a number of iterations, Xstream being one of them. So using Xstream API, you can redo log data and land it into Snowflake. The next one, you see, there's a reason why I've colored it red, because this is brand new an addition to Snowflake Summit 2026. What is it? It is again ingestion, but it is Kafka-compatible ingestion. So real-time streaming ingest is a hugely critical topic. And you see everybody is doing it now. Microsoft Fabric is heavily into this space. When we look at Databricks, you'll see there's something called Zero Bus API. Same idea. IBM bought Confluent. So they get this whole Kafka technology built is being integrated deeply into IBM's Watson Extra data. What Snowflake is saying is that yes, that's good, but you still need to stand up a Kafka cluster. Although Kafka now has simplified, they don't need Zookeeper, but in the past, you still needed it. So what DataStream does is, because it's Kafka compatible, if you have Kafka producers, then Snowflake can read the data from producers natively and then write it into Snowflake. And because Snowflake is not supporting Iceberg, so it could be even written as Iceberg tables. So that way, as soon as new data arrives, it is available in Snowflake for querying. Why? So why bother building a Kafka compatible thing native to Snowflake? That's because if you have separate clusters for Kafka, for Snowflake, for something else, each needs to be governed. And now through DataStream, it comes under the whole governance, security, privacy, RBAC, encryption, all of those that Snowflake already has. So you don't need to have separate governance. Not to mention, as this slide says, it's a $128 billion streaming market. So this takes Snowflake into an expanded orthogonal market. So that's ingestion. Now let's move to transformation. So what I'm trying to also do is give a flavor of what already exists and what is new. So here I have two types of you can see transformation approaches. Both are headed by Snowflake CoCo. As I promised, you'll see Snowflake CoCo show up over and over, which is this natural language agent in which I can tell what my intent is, and it can create the pipeline for me. So that's the overarching piece. But if we dig deeper, there are two approaches to doing data transformation in Snowflake. The first one on the left is more declarative, more SQL based, where I either write my SQL or I declare the intent, SQL gets created. The other one is more programmatic or imperative, where I write down in code what exactly I want. If I want something very detailed with a lot of if-then kind of thing, then I will use imperative. I would write my Python script with Spark APIs and then run that. So on the programmatic piece, you have two options. Either you can run Python natively on Snowflake using Snowpark. Remember, Snowpark is the containers. So you can write your Python. It's like PySpark, kind of an idea. It runs in Snowpark out of the box. You don't need to do anything. But the other option that was introduced is something called Snowpark Connect. So Snowpark Connect is this ability to run your existing Spark jobs directly on Snowflake. So that is something new. Now, if you go on the declarative side, so here things are very different. So I can write my SQL statement or I can have CoCo generate SQL queries on my behalf, and I have two options. Either I can have it be converted into dbt core, which is the open source option of dbt, and then that runs natively inside Snowflake in something that was introduced last year called dbt projects. Or I can take the SQL, I can declare the intent, and I can use something called dynamic tables. So I talked to a lot of people who swear by dynamic table. These are end user customers. So it has simplified very difficult SQL joins into a very simple dynamic table. Dynamic table is like a declarative pipeline. You specify your intent, you specify how quickly you want the refreshes or the process to be run, and then the declarative pipeline will take your code and it'll just continuously run it. For example, you may say that read this data from the source and then load it into Snowflake tables. And so what is new in 2026? You can see dynamic tables are now 2.8x faster, and there is now ability to add a where clause in dynamic table, where you can say only look at the rows that have changed or put some other condition in the where clause. So you now have this ability to refine dynamic tables. Whatever option you choose goes to Snowflake engine, and then it goes to the storage. So moving on. So let's talk about storage. What's happening there? So Snowflake and same week Databricks both announced that they are going general availability with Iceberg version 3 specification. In fact, by end of 2026, version 4 is expected to be out. By the time version 4 comes out, the idea is that the difference between Iceberg and Delta Lake is going to just disappear. They'll both be at parity. Even today, Iceberg V3 has introduced a lot of new features. These features are, in fact, borrowed from other places. When Netflix created Iceberg, they were not that worried about streaming ingest, for example. When LinkedIn created Hoodie, they were very much concerned about new data that was coming in. So streaming ingest was really big in Hoodie, but not in Iceberg. So now what we see is support for variant file type. So this is semi-structured document model, JSON, what MongoDB does. So now you can natively store variant. There's a very strong support now for geospatial data, for row lineage. And very important, deletion vectors. Deletion is a very complex job when you're working at file level, like Parquet files. It's unlike a table, you can just delete a row. You have to manipulate the file, the versions of files, and it takes a very long time for deletes to be handled and made visible in table format like Iceberg. So there's now a much more efficient row level delete. And so these are a few changes that you see in Iceberg V3. Next year, when we go to Snowflake Summit 2027, hopefully you will see that Iceberg will be at version 4. By the way, although I mentioned it's now GA in Snowflake. There are only a tiny number of companies that support V3. So the support for V3 is yet to come. A lot of like maybe Athena or some of them may still be on V2, although by the time this video comes out, things change so rapidly. But this was a very big thing. Okay, so now Iceberg is a very interesting thing. It started as a table format for storage, but it morphed into catalog. And we have a whole section on catalog, but I want to talk about this sort of dual role that Iceberg plays. So what Snowflake did last year was they said we will support Iceberg. It could be anywhere. It could be on your AWS account in your S3 bucket, and we can then link to this externally managed Iceberg table through Snowflake. So in Snowflake, you would do a create table and you would indicate it points to the Iceberg format on S3, and it would create the table, but pointing to externally managed. Then they said, oh, don't worry about it. You can also have create Iceberg tables and have Snowflake manage it. These are still at catalog level. This year, in 2026, Snowflake introduced something very interesting. And see, this is very confusing because you see how close these terms are. So now you have something called Snowflake-managed Iceberg Storage, as opposed to tables. So what Snowflake announced was that now inside of Snowflake, you can create a locally managed Iceberg table. And when you do it inside of Iceberg table inside of Snowflake, then you inherit all of the Snowflake conveniences. For example, in a normal table that you create inside Snowflake, you get failsafe. Failsafe is disaster recovery, time travel for 7 days. All the changes to the table are persisted at no additional cost. It's just what Snowflake does. Failsafe gives you an additional 7 days. When you create an Iceberg table inside Snowflake, since it has control over storage, it gives you that failsafe. But if you want a cheaper option, Snowflake also has something called transient tables, which is basically tables with no DR, no failsafe, but they're cheaper. And so now you can even create your Iceberg table as a transient table. So because it's Iceberg, so external engines like Spark, Trino, they read the data directly in Snowflake. So basically, the whole idea is that you no longer need to have an account on AWS, S3, or in Azure, ADLS, Blob Store, or in Google Cloud, or on GCS. You can create native Iceberg tables. One more thing I wanted to add here is it's kind of orthogonal to what we are talking about, but we are very rapidly also moving into an era where you don't always have to copy data from source to target, although every lakehouse vendor would want you to do that because they won't be able to manage your data and the storage and compute that comes with it. But now we are in this very interesting world of zero copy. What zero copy example is SAP, for example, is a first class citizen now to Snowflake, Databricks, AWS, Microsoft Fabric. And as soon as SAP data changes, what happens is that the change data is then there's a copy made in Iceberg table format. And zero copy means no need to move data, just need to synchronize the catalogs. So you synchronize SAP's catalog with Horizon catalog, which is something we are coming to in Snowflake, or Unity catalog in Databricks. And all of a sudden, if I want to discover new data in Snowflake, I can read and find out what SAP data exists. And then I can write my query. My query is written locally in Snowflake, but it's actually federation behind the scenes. It is sending it over to SAP to get executed. So I wanted to mention, since we are talking about storage, that this is the world we are moving into, which is more of Iceberg REST catalog, bidirectionally synchronized between external systems and your lakehouse. Okay, so we have already started talking about catalog. In catalog, there are two options. The technical metadata catalog, the one that shows information at the schema level, is called Polaris. Polaris is a Iceberg REST catalog, open sourced, created by Snowflake and I believe Dremio, but it's anyone can use it, and it now has REST endpoint support, both read and write to Delta Lake and Hoodie. So this read and write is very important. That means you can have Trino read from Polaris what tables exist, and then if it does any writes, it can write it. Spark, for example, can write it back to the underlying storage. Using Polaris, what Snowflake has done is they've built a layer above Polaris. It's called Horizon Catalog. Like I said, Polaris is technical metadata, but what about business metadata, business glossary, where you're defining terms? All those things happen in Horizon. Horizon is also where you do all your governance. So all the policies, role-based access control, that exists in Horizon. So the way it works is, so you've got Spark and Trino. They can read and write Iceberg tables, like we just said. But also, there's something called catalog linked database that was introduced, which is exactly what I was talking about, where SAP data, for example, is now queryable, no movement of data. So this is the advanced data integration use case that we are seeing. So this is how you discover, you query, you do reads and writes across any Iceberg REST compatible storage in Snowflake or outside of Snowflake. But what about sharing of that data? So that is done by Snowflake in what they call open data sharing. Many years ago, you had to be a Snowflake customer to be able to see the data that belongs to you. For example, let's say a very large grocery store chain has data from its suppliers and vendors. So let's say a company like Coca-Cola wants to see what kind of sales took place in this large grocery chain. So they won't only be able to see their data, obviously not Pepsi's data. So without having to extract the data from Snowflake and then secure FTP it or email it or use some of these insecure connections, you basically can now do open data sharing. So Coca-Cola's data team can log in and they can see all their data. They don't even have to pay for storage. They may already be paying on Snowflake side, but if they make a copy and start running reports, then they pay for it. Now, one thing that I find super interesting in this space is this whole concept which has been introduced called Open Semantic Interchange or OSI. So we are now talking about semantics, not context. We'll come to context on the next slide. What is semantics? Semantics is the business meaning of my raw data. Like, for example, the column names could be cryptic, but I may say this is customer identification. It also dimensions, facts dimensions, also business rules, calculations, metrics. For example, what is a common definition of ARR? For example, annual recurring revenue. You may have, like, different people have different definitions in different departments, but by defining a semantic, you can now say this is the authorized definition of ARR. So that's a semantic. So where do you store that semantic? So this is a very confusing topic because semantics could be in your BI layer, they could be in your data transformation layer, they could be in your data catalog, they could be in your database. There is no perfect answer. Either place you pick, there will be some trade-offs. You may get locked into your BI tool, you may get locked into your database platform. In Snowflake, they like to store it in the data platform, and that is called Snowflake Semantic Views. So, but now if you were to use a different data platform, your semantic definition is locked into what's inside Snowflake, not anymore. And that is because if you choose OSI as a standard, then it's interchangeable. It's an interchange format. So it's literally a YAML file. And you can take that YAML file and you can move it to another OSI compatible data source and off you go. Now that data source has the same semantic definition. So how powerful this is? dbt supports it. BI tools like Hex, Looker, they also supported. So what or Tableau. So I can now define my semantics in any layer, and I can push it down anywhere in the stack as long as it's OSI compatible. One place that is a powerhouse in BI, especially when it comes to semantics, but does not support OSI, is Microsoft's Power BI. So there's a disconnect here because they want to protect their proprietary way of storing semantics in Power BI. So at Snowflake Summit 2026, a company called AtScale, they produced sort of a bridge. It turns out that Power BI, Microsoft Excel, they write their semantics in something called XMLA standard, and then they bridged XMLA to OSI. So that way now even a tool that does not support OSI but supports XMLA like Power BI or Excel can share the semantics. So that was something that AtScale introduced. All right, so let's move to the context side of it. Context is probably the hottest topic in 2026. And why is it so hot? Is because every natural language tool that a knowledge worker is using and giving business directions needs some sort of translation, understanding of what the user is asking and then what data is available, not in my existing system, but also all my other systems that connect to it. For example, I may have my customer data in Snowflake, but my transactional data may be in Oracle. My CRM data may be in Salesforce. So if I ask a question in CoCo, or co-work, then it needs to be able to create a context graph of data that's in different places, create some relationships, and then be able to serve it. So Snowflake, like everybody else, rose to this challenge in two ways. One is called explicit. Explicit is where the business is defining what the context should be. And that is done in a new product that was launched called Horizon Context. And then there is the implicit option where AI is, through its very strong ability to do similarity connections between different sources, it is implicitly generating that relationship, and that is something called Cortex Sense. Cortex Sense actually belongs to something that we see at the very end called cowork. But I added it here because we are talking about context. So this context is across different places. Now, last year, Snowflake acquired a company called Select Star, which is a data catalog company. And using Select Star, it is now able to have these connectors from Snowflake into external systems to extract metadata, find similarity and relationships, and then also support lineage using another open source approach called open lineage. So a lot of things are taking place in this. This is one of the biggest topics in discussion right now. So we are going to move on, but before we move on, the topic of catalog needs a whole podcast, even series of podcasts in the space. So I have only literally touched upon a few things. If I look here at the catalog, you see we've talked about open lineage, we talked about semantic views, but catalog also helps with data quality, access control, RBAC, ABAC, sensitive data protection, which we are actually going to talk about, AI security and guardrails. So it's a very comprehensive thing. Iceberg REST catalog API is the most common, but then you have SQL and REST APIs. Also, MCP server is something we have not talked about, but through MCP, it can reach out to OpenAI, Cloud Code, cursors of the world. And then beneath it, it can look at Snowflake tables, proprietary format, Iceberg tables, external systems, like we've talked a lot about SAP, but Salesforce, Workday, all of these other ones, Postgres database, Oracle, MySQL, and then through other data transformation tools like DBT, because it has to extract transformation logic to be able to show that lineage. So that's pretty much what we'll talk about in catalog. Next, we move to security and governance. I really like how Snowflake made our lives very easy in explaining what transpired in the space. Yet again, it's a whole podcast by itself, and also very, very detailed. But what they did was something very nice, is that they basically said there are three types of security enhancements. The middle one is where we start with, which is data. You secure your data, you secure your platform, and then you secure the agents on top. So those are the three layers. So data, platform, and agent is how they look at. On top is all your AI stuff, very detailed thing. So data security, and we'll talk more about it on the next slide, but since I have this really nice graphic, so let me talk about this. Anything that you see is in purple box is 2026 new enhancements. Data is at the very bottom. You have to understand what is in your data before you can apply any security on top of it. So something that's new is now Snowflake has, I believe, 150 LLM-based classifiers that can go and look at different types of data sources, and it can tag it by saying this is PII data or PCI data or HIPAA or requires GDPR overview. So automatically LLM-based classifiers is a very big thing for sensitive data protection. You can create all kinds of data exfiltration protection, ransomware protection. So these were some new things. Now, if you move to platform security, nothing is in purple, which is the whole point, is that platform is solid. So you don't really need to necessarily force fit some new security posture. So all the things like multi-factor authentication, single sign-on, RBAC, ABAC, network security, OAuth, all those things fall under platform security, and this one is pretty solid. What is new is on this side, which is agent security. So agents are working on my behalf or your behalf. So they need to have an identity. So one of big announcement was this thing called agent identity. How do you define the identity of the agent so the agents only get to see and do prescribed actions? So that was one of the big announcements. All of security configuration, setup, single pane of glass is through something that is called Trust Center, which then works closely with Horizon Catalog. So here are a few things that I've already talked about. I have more details in my blog than what I'm covering here. You can see we talked about LLM classifiers that auto detect. We basically mentioned platform security is unchanged because it's a very stable base. But in agent, every agent gets a verified identity. And so interestingly, the only acquisition that comes to my mind for Snowflake at Summit was announcement of a company called Ntoma. What does Ntoma do? As you can see, it's an enterprise MCP platform. The idea is, let's say I have a personal agent. That agent goes, reads my email, understands the intent of a new email. Based on that, it's going to reason, create a series of action items, and then do some sort of chain of thought, reasoning, and then go take action. That action may be based on this incoming email. I have to open a Jira ticket, or I should send a Slack message. Each time it's going through an MCP server to that target. So how do you manage this identity and MCP connections from agents to external systems is something that Ntoma does really well. And now it was just announced just before Summit, so it hasn't closed yet, but this acquisition is expected to close very soon. And so next year we see what effects we have of Ntoma acquisition. Finally, after a long series of announcements, we are into the AI ML space. And my point here is to show that while it's sexy to talk about AI, there is a lot of sausage making that goes behind the scenes for it to be successful. By the way, I didn't mention CoCo explicitly, but I mentioned in data engineering, creating map pipelines. I didn't mention it in governance, but the whole idea that Snowflake introduced was something called intent-based governance, which is state your intent and in natural language. And then, like for example, my intent could be go identify all the sensitive data in this source, or maybe I don't even mention source, and mask it or redact it. So that's a statement I'm giving in natural language. it then goes, figures out how to do intent-based governance. So, so CoCo is built and CoWork are built across the board. What is CoCo? It's a coding agent. Actually, it was Cortex code, but people abbreviated Cortex code to CoCo, and then Snowflake was like, "Oh my God, this is amazing! Let's just call it CoCo." And so they went ahead and rebranded Cortex code. It is for developers. It is meant to write your AI workloads. In fact, what you do in CoCo is you can pick which model you want to use. We know every day, every week, there are new models that keep coming out. For example, as I'm recording this, Anthropic Fable 5 is now finally available once again. So maybe I want to use Fable 5. Or if for some reason I decide that, cost is very important to me, I'm going to use one of the Chinese open source models like DeepSeek or GLM 5.2 or something like that. I have the ability to change the model. So if we look at it this way, then what happens is that CoCo is not just an agent, it's a harness. Within CoCo, I can say, here are the tasks I want you to do. Each task should get its own sub-agent. Each sub-agent could use a different model. For example, Google's Gemini is really good at, let's say, video generation through Nano Banana 2 or translation. But Claude could be better at some other task and OpenAI for something else. So I can have sub agents, multiple MCP servers. I have to manage memory. One of the jokes that we constantly heard was the fact that people in San Francisco are walking around with their open laptops because they're running agents. And if they shut down their laptop, then the agents will stop running. So CoCo introduced this ability to run agents on server side. So you can go on that date without keeping your laptop open next to you on the table because you're running some agent. So also, CoCo is available as CLI. I know a lot of people who use CLI because they're developers, but if you are more interested in a UI based, you can use CoCo through Snowsight, your favorite IDE, VS Code, Claude Code. One thing that I have not mentioned here is also CoCo Desktop was also introduced. So CoCo is for developers. CoWork is a personal agent for knowledge workers. So this is for non-developers. It does a huge number of things. I've only mentioned deep research, analytical search, but there's a lot of functionality that I've mentioned in my blog. One of them is something we talked about, which is Cortex Sense, which is to create this context layer automatically. So behind the scenes, you've got Cortex Agent, which is the one that is creating the engine, and that Cortex agent actually has two underneath things that it's orchestrating. Cortex Search is doing RAG on my documents like PDFs, contracts, wikis. And then Cortex Analyst is doing text to SQL on structured data. One thing that I want to also mention is that we have not yet seen training of small language models or fine tuning of open weight models at scale. And that's because it is difficult to do if you get your weights wrong because knowledge workers are not data scientists, then you can degrade that open weights model rather than customize it to your data. So there are a lot of challenges in training, fine tuning large language models. what Snowflake announced was something called Cortex training that allows you to train the model on your data inside Snowflake, which A, reduces the cost, B, it's working in a very secure environment because it's inside the security parameter that you already get out of Snowflake. So that is a brand new area in the era of token maxing. This is something that could be a very big space for Snowflake going forward. Snowflake itself is not just giving you the platform, but it is also creating these agents. There are several agents they talked about at the summit. I've only mentioned one of them, which is this last one called Raven, because Raven is something that the entire sales organization uses almost on daily basis before they go see a client or a prospect. This is where they can research, and last I heard, it had saved Snowflake something like $16 million by using Raven. So, with that, we are going to bring this podcast to an end with a little bit of summary. So, agents are the new consumers. Open standards have become really important, and Snowflake is going from just being a cloud data warehouse or cloud data AI platform into a substrate through a lot of these acquisitions. We talked about Crunchy, DataVolo, SelectStar, Ntoma. One that we didn't talk about is Observe. And Observe is very exciting because Observe takes Snowflake into the whole world of telemetry data using open standards once again, like OTel, open telemetry, writing the content to Iceberg. What it's doing is it's telling customers who are used to using tools like Splunk, and Splunk builds up pretty high, that if you come to Snowflake, your telemetry data is going to come and reside where your other data sits. It's in open standards, and you can now do IT ops kind of use cases right inside Snowflake. So, with that, we will end our podcast here. Thank you so much for joining. The next episode is going to be on Databricks Summit 2026. Thank you very much for staying till the very end.